Hi everyone, I'm Jeremiah, a cybersecurity expert and an AI enthusiast. And I'm passionate about driving real-world solution about security challenges in graph-based threat analysis. I joined the hackathon to explore how AI and graph database like ArangoDB can ensure cybersecurity by detecting vulnerability dynamically. So we get our credentials and then we log into ArangoDB. I use the temporary login cloud version. When we are logged in, up next is to use our data set. So for the purpose of this video, I use the CVE dataset, which has about 95,000 entries, which is quite voluminous. So we are going to use this test before we go to the larger data set. So this test only has 4 entries, so we're going to see how GraphRag works alongside with AI. So we used edge. For the edges, the connections between CV were exploited, and the graph visualization shows a diagram of how the dataset was converted into ArangoDB graph. So we used NX, ArangoDB, and cuGraph. So if the user doesn't have NVIDIA, he can always fall back to his CPU. So the first step is to load the database to data sets. This is the actual graph. This is the actual notebook file. We're going to be using the CV with 1,095,000 entry, but this is a test to just reduce the workload on the CPU that we're going to be using. So when we come to our notebook, we've already installed our dependencies. We run this Python script and we see how it responds. So let's do that. So we are done. So when we head back to our ArangoDB at the graph, so we could see that only 4 nodes were formed, and the collection database also, our data was basically populated. We'll see that if we run it with LLM connected, we can actually fetch data, meaningful data from this graph. So let's see how that works. So we could see that the LLM actually responded, and we could use this in a whole lot of scenario. Our prompt was this. Let's see. Okay, I'm just going to bring this up so we could see it a bit. Yes, so here was our prompt. Is it what vulnerabilities are present in the graph? So this here was our prompt. We could also ask it a lot of questions. Now this is very much useful not only in the space of this graph alone, but is actually very significant in the world of cybersecurity. We can use RAG graph to actually get data, and we could connect this to, for instance, we could connect it to webhook, we could connect it to maybe Telegram or whatever software that we want, and it makes cybersecurity handling more efficient thanks to RAG graph and ArangoDB, cuGraph, and the likes of them. So here was the graph that was created for just the test network, which we used. It was able to fetch relevant data from this graph. Here was also our data collection, all the data that was fed from this particular source, okay, got into it. So moving on, let's run the main data which has 95,000 lines. So for that, we got our data source, which was provided by ArangoDB. We got it from Cargo here, which is CSV, that's for vulnerability data. So we're going to be loading this. So in this case, we might require our GPU. The name of the file is called vulnerability graph main. So when we run it, it reads from this long CSV file, which are data sets. So it computes the edges and the node. You can see that's happening live. Then it uses CPU with network X, and it tries to determine the PageRank score using PageRank algorithm. But we should know that using the CPU was just a fallback for people that do not have GPU and want to run the algorithm. So we provided also provision for GPU. So if you are using Touch with CUDA, you could actually use GPU and it will hasten this. But because we're not connected to our GPU, we're using the CPU. So this will take some time. I'm just going to show the graph, and of course we've seen how the response would be. The LLM goes to the graph and it determines the response. So from the new one that we created, here is it, graph main. When we open it, we see that a lot of graph nodes has been connected. So the better the data that we collect, the more efficient it is for us to secure our network or our software in the cybersecurity space. So the advantage of this thing is very vast and is very voluminous, one of which is to strengthen a system's network from hackers or vulnerable spots, that is blind spots, and also to make the knowledge that you have on cybersecurity to be improved. So AI powered threat detection, thanks to ArangoDB, is very achievable. Thank you.